Question 1. We need to determine whether this is a probability distribution. In order to do that, we need to add all the probability values for each event. We're going to add these values here. Use my summation. Enter. We find the value is 1. What that means is we do have a probability distribution. The answer is yes. Question 3. The problem is, for the outcome 2, we have a negative probability value. Probabilities are between 0 and 1, so this cannot be a probability distribution. Question 5. Question 5, we need to determine the mean of this distribution. Do we have a distribution? Let's add our probability values. We see that the values are 1, so we do have a probability distribution. Now, in order to compute the expected value, mu equals the sum of x, all the outcomes, times their probabilities. X times p of x for all x. This is how we compute our expected value, or the mean, for a probability distribution. So as you can see, I created an x times p of x column. I now have to multiply my outcomes, hit equal, highlight the cell, the first outcome, which is 0, times the probability of 0, and hit enter. Now it makes sense that 0 times 0.19 is 0. I am now going to use the autofill feature. Go to the lower right corner and you have a black cross. Once you have your black cross, right click, hold, and drag. We have performed all the necessary products using autofill. Sum your values. We find that the mean is 2.25. Question 7. We need to determine the standard deviation for the given probability distribution. The standard deviation, represented by sigma, is the square root of the variance. However, the variance is equal to the sum of x squared times p of x minus mu squared for all x. So we have to compute an x squared px column, add those values, and subtract the square of the mean. This is why I have an x squared px column, and we have to determine the mean for this distribution. Let's add our probability values to determine whether we have a distribution. The answer is yes. We need the values for x times p of x. Highlight the cell, equal the first outcome times its probability, enter, is 0. We're going to use the autofill feature. Lower right hand corner, dark cross. And we get what we're looking for. Compute the mean. Add those values, and we find that it's 2.39. Let's find the x squared px column of values equal. I'm going to use a parentheses, the first data value, raised to the second power, times its probability. And we get the value 0. Going to the right hand side with our dark cross to use the autofill feature, right click and hold and drag. We form all these products. Take the sum of these values, and we get 7.53. We're going to use this information to compute the variance, which will then give us our standard deviation. Let's go back to the formula. We're going to use this value and subtract the mean to the second power. I'm going to enter 7.53 minus 2.39 raised to the second power. This gives us a value of 1.8179 for the variance. However, $1.8179. This is our variance. However, we need the standard deviation. Standard deviation is square root of the variance. Standard deviation is square root of that value. 1.8179. Let's take the square root of that value. Second square root 1.8179. Hit enter. Question 7. If we look at this value, it is 1.3482952. In the solutions, they want us to approximate this answer to the nearest hundredths. Tenths, hundredths. The 4 is in the hundredth position. The digit to the right is an 8, which means we add 1 to the 4 so that your answer will be 1.35 for the standard deviation. Question 9. Question 9 is a game in which you need to compute the expected value. Now there are two outcomes. You can either win the game or you can lose the game. What they indicate is that losing this game takes $9 out of your pocket. So we'll enter a -9 value for the outcome of losing. And what they tell you is that you will be winning $106. What they didn't mention or necessarily make clear is that this is a net value. This is going into your pocket. So we will put a 106 for winning. The probability of winning this game is 1 over 29. While the probability of losing this game is the complement, or 28 over 29. By using the definition of expected value, we are going to take the 106 value and multiply it with the probability. We are going to take the -9 value associated with losing and multiply it with its probability. What we'll put over here is the sum. Adding the two values leaves us a -5.0344482.759. Now this is money, so we are going to adjust the accuracy so we can approximate this to the nearest penny. Ladies and gentlemen, the answer is -$5.03 for an expected value. Question 11. Question 11 is another game. It's a game in which you can either win or lose. In this game, they tell you you get $4 back. However, what we have to note is that losing this game costs us $2. So we're going to put a -2 for losing. And winning this game, although we get $4 back, 2 of those dollars were our dollars. They were our own. So $4 back and 2 of those dollars re-put down to play the game leaves a net of $2. So let's emphasize that this is really a net value. Now, we have to determine the probability of winning this game. In this question, they tell us we win by rolling a die. And in order to win, we must roll a 5 or a 6. So the probability of rolling a 5 or a 6 by the addition rule is the probability of rolling a 5 plus the probability of rolling a 6. We know that's 1 6 plus 1 6, which is going to give us 2 6. And that reduces to 1/3. So we're going to enter the probability of 1 over 3 for winning. Now losing, on the other hand, we can take the complement, which is 1 minus the 1 over 3 value, and we get the probability of losing. Using the definition of expected value, we take the $2, we multiply it with its probability. we take the negative $2 and we multiply it with its probability. Finding the sum of these two values is going to give us our answer. And let's put this in money form. There's way too many decimals. So approximating to the nearest hundredths position, which is the nearest penny, the expected value here is a negative 0.67. Question 13. Question 13 is an insurance question. With insurance, you can either live or you cannot live for your outcomes. Now, living will cost you $208. That's going to come out of your pocket, so we're going to put a negative 208. However, this policy is a $110,000 policy. So if you do not live, what you'll get, or your beneficiary will get, is that $110,000 minus the 208 you put down. It is similar to gambling. You are looking for the net value. $110,000 minus 208 is $109,792. Yet again, let's emphasize that this is the net value. What they say for us here is that the probability of living is 0.9993, and the probability of losing or not living will be 1 minus the probability of living. So let's say that again. The probability of living is 0.993. That's 3 nines and then a 3. The probability of not living is 0.0007. It is what we see here. Using the definition of expected value, we will take the negative 208 and multiply it with its probability. We will take the 109,792, multiply it with its probability. If we take the sum, we will find the expected value. The expected value for this $110,000 policy is negative $131. And this is how you answer question 13.